Hey everyone, welcome back to the channel. With this video, we are moving forward in our linked list playlist. If you haven't watched our previous video, I would recommend you to check it out first. So without any more delay, let's jump to the problem. The problem is to find the middle of a linked list. You have given the head of a linked list and you have to return the middle node or middle element of a single linked list. So for the example one, your linked list is containing 1, 2, 3, 4, 5, and you have to simply return the 3 that is the middle. And for example 2, you have to return the 4 that is the middle one. You can say why 4 is my middle one, why not 3? Because you have to, for even number, you have to return the next of them half. So what will be our brute force? Our brute force will be first counting out how many elements are in a linked list. For the example one, there are 5. So we'll first in illustration you will count how many nodes are in the linked list. That will give a 5. Then you will simply divide it by 2. That will give a 2. And again you will start iterating in the linked list. You will reach 2 and you will simply return the next of that mid value of your half of the node. Same for the example 2. In this case there are 6 elements or 6 nodes. You reach here and you simply return the 4 of its next. So that will be the brute force. But in this video, I will be teaching you an amazing technique called fast and slow approach. What is a fast and slow approach? Or you can say a technique. You will be solving many questions using fast and slow, like cycle detection, insertion, intersection point of two linked lists, middle of a linked list. But what is this? As the name suggests, slow and fast. It's like a turtle and hare problem or thing. The slow will move to the one step in one go. The fast will move two steps in one go. So what it means? It simply means when my slow is here, they both are pointing at the head at first. But my slow can move one step. Means my slow is move to the two. Okay. So my slow moves here, but fast moves two steps. So from here, from one, my fast moves to the three. Then again, my slow was here. It moves to one step. My slow reaches here. And same for the fast. My fast was here at three. As you can see, my fast was three, and in the fast can move two steps, so it goes to the five. And again, my slow reaches here from 3 to 4, and my fast reaches 5 to null. From 5, it reaches the null. Cross means null, there's nothing. So, the moment the fast reaches the null, there's nothing to traverse. So, you can stop here. And you can observe one thing the slow is pointing to the slow. I mean, 4, the mid value. That's it. That will be applicable to any linked list, any single linked list. You can see by in this example when my slow was here and my fast was here, slow moves here, fast moves here. Okay, two steps. Then again my slow moves here, my fast moves from 3 to 5. Okay, so the moment my fast reaches here, you can stop because after the right of 5 there's nothing, so you can stop here basically. So you can see the slow was again pointing to the middle of the linked list. So that was the intuition behind the slow and fast approach. It was easy, but let's code it up. Let's try whether it's working or not. I will code in all three languages: C++, Java, and Python. I will provide you the timestamp. If you're a Java user, directly jump to the your Java solution. So what we need first, I'm coding in a C++ first. So what we need? We need a list nodes type. We need a slow. It will be pointing to the head, and we need a list node fast that will again be pointing to the head. Now, what will be our Like I said, we need to traverse in a linked list. So I will traverse in a linked list. There will be some cases. Okay, what I need, what I have to do, I have to move my slow to the one step. So basically, slow. I will say slow move to your next. So slow will move to its next. And same for the fast. I will say fast move to your next of next. So fast will move to the next of next. So what will be our base condition in the while loop? From where we have to terminate our while loop. Let's see. Uh, for this example, when the my fast reaches the null, okay. But here my fast didn't reaches the null. It was the end element. Means when the my fast reaches the end element, you can stop here, or my fast reaches to the null. Okay, so just wait a second. So my fast should not be null. My first condition will be fast shouldn't be null, and my next of fast, my next of fast is also shouldn't be null. Why? Because it's the last element. You can't go further. And what we have to return, we have to since I have said that at the end of our while loop, the slow will be the pointing to our mid. You can just simply return the slow, and I think this should be working fine, and it's working exactly. Let me copy the whole thing for the Java solution. Okay, it run. Let's run the Java code now. So in Java, what we need, I will copy the whole thing. And in Java, we don't have any error function. So simply just the point dot next. And here also fast dot next. And we don't have any pointer concept in Java. So let's remove the whole thing. And I think this should be working in the Java. You see, okay, because we have to change to the small null. Now it should be working. It's work. Now let's move to the Python. It's time for the Python code. In Python, you can just simply assign slow as head, fast as head 2. What we need a while loop. And what's the condition? Fast and fast dot next. They both shouldn't be null. And what we need in a while loop? In while loop, we need I will just say slow move to next. So slow will move to the next. Fast will move to the fast dot next. And after the while loop, I will simply return the slow. And I think it should be working, and it's working. So let's submit it up. With this, if you like my video, please subscribe and like my channel or video. If you have some query or comment, do comment below. With this, thank you all.